So today we are going to see the problem, to solve the problem by using Moodi chart. So let us start. So this problem, there is a water tank and water is flowing through this sharp edge entrance. So there is a entrance. So we'll consider the entrance, K factor for entrance. Means there will be a head loss due to this sharp edge entrance, due to this 90-degree elbow, then again 90-degree elbow, gate wall, exit, and the friction factor due to Darcy. So let us will start. So we'll write the first given data. So diameter is given, d is equal to 0.15 meter. So it will help me to find out the area. Area is equal to pi by 4 d square. So it is pi by 4 into 0.15 square is equal to 0.0177 meter square. Okay. Then psi by d is given. Why it is given? I will tell you with the help of Moodi chart. It is 0.017. Then a kinematic viscosity is given. Nu is equal to 1.01 into 10 to the power minus 6 meter square per second. So this is a kinematic viscosity which is used to find out the Reynolds number. Now, so if you see the water is flowing through this pipe with the 30, the length is 30, then about 12, here it is given 12, 30, 12, and then 60. So total length of the pipe you can find out L is equal to 30 plus 12 plus 60 is equal to 102 meter. This is the total length of the pipe. Now here, as I explain you what are the head losses we will consider here. So let us K1 is the head loss due to entrance, and K factor for the entrance, surface entrance, and its value is 0.5 for entrance. Then there is a 90 elbow, so K2 is equal to K3 because both same elbow. So this is K1 and this is K2 and this is K3 and K globe wall. So I'll assume it is K4 and K5 will neglect or ignore. No exit losses. It is almost 1. So K3 is equal to K4. It is from the chart which is given to you. Yes, here this is the chart, and here we'll find globe and all this. So these values are given to you, and it depends on the manufacturer of these elbows. So it is not so important what value you choose. But if you see the globe wall, the value is 10 because there is too much hair loss at the globe wall, as it is a controlled wall. So K3 and K2 is, we will assume it 0.9 for 90-degree elbow. Then K4 is equal to 10 for globe wall. And K5 exit, we will ignore it. K5 is equal to 1 and it is a, we will ignore this wall. So we'll apply the Bernoulli's equation, and as this end, one end is open and water is storage, so velocity is 0 here, and this also open to atmosphere, so pressure both end at 1 and 2 point pressure is same, so it will get cancelled. So after applying the Bernoulli's equation, after applying Bernoulli's equation, we can write the total head loss H1 is equal to V square by 2G. I will take the common because it will be multiplied to. Okay, so this is a kinetic energy. The head, velocity head available at the entrance at the point number 1, then plus the head loss due to Darcy friction factor FL V square by 2G D plus head loss due to entrance and elbows and globe wall with a different case. So K1 entrance, K2 plus K3, that is 90 elbows plus K4 globe wall, and exit I will not use it, and this is the velocity head. So after applying the Bernoulli's equation we will get these values. So let us put all the values and we will write the equation H is equal to H1 is equal to V square by 2G plus F I don't know, L is 102 meter divided by diameter is 1.5, Ef by F V square by 2G plus V square by 2G. I don't know the velocity, so entrance is 0.5 plus 0.9 plus 0.9 plus 10. Now we will take the V square by 2G common. So V square by 2G, we don't know the velocity, it is asked. V square by 2G is equal to, or plus, I will simplify this, plus 680 F V square by 2G plus 12.3 V square by 2G. So 0.5, 9.8 and 2.3 and 10, 12.3. So 12.3. Now we will take the V square by 2G common. So H1 is equal to V square by 2G, that is this 1 plus 12.3, that is 13.3 plus 680 F. So now we'll name this equation 1. Now in this equation we don't know velocity F and H is unknown. It is not given in the problem. You can see here the discharge through the pipe in the figure if H is equal to 10. Now, so for A we will solve. So for A option, so it is asked to find out Q, means we need velocity. To find out velocity we need either H, so H is given as 10. Then we need F. So we need V and F. So V and F is unknown. So V and F is unknown. So we can't solve this above equation. So we need to use Moodi chart. So by Moodi chart, So now I will explain how to use the Moodi chart. Now here, xi by d is given as 0.0017. So your value is lies near about, this is 0.001. So near about, this is 15. So here 0.0017. Okay, so I will draw the parallel curve. This is the parallel curve. So now, first assumption, we will assume f is equal to, we will assume f is equal to 0.02. So here 0, 2, 4, this is 2, 4, 6, sorry, 0.2, 1, 2, 3, 4, and this 25. So 21, 22, 23, 24, 25. So we'll assume f is equal to 0.0022. Okay, so this line will come along with this line until that curve. So let it 2, 3. So we'll go to 23. This is 21, 22, 23 from this line. It will cut here near about here. So this will cut here and we'll find the Reynolds number as somewhere here. Yes, here. So Reynolds number is near about 5 into 10 to the power 5. So R is equal to 5 into 10 to the power 5. So if you assume f is equal to 0.3, Reynolds number is 5 into 10 to the power 5. Okay, so we will check it whether it is correct or not. So by hit and miss method. So first assumption by trial and error method, by trial and error method, by trial and error method. So assume f is equal to 0.0023 and psi by d is equal to 0.0017. Will get a Reynolds number. A Reynolds number is 5 into 10 to the power 5. Okay, so this we get it from the Moodi chart. From Moodi chart. From Moodi chart. Now we'll check this. Once we know the Reynolds number, we'll find the velocity. So if you put these values in the equation number 1, F we have, H we have, we'll get velocity, and we'll check whether Reynolds number is same or not, and then we will decide. So by assumption, so from equation 10 is equal to, from equation 10 is equal to 10 is equal to v square by 2g 13.3 plus 680 into 0.0023 0023 or 023, not 00. So 10 is not there. Yes. So 2, 3. So we can solve this value. We can solve and we can find V is equal to we'll get so 10 10 alpha equal x square alpha bracket x square divided by 2 into 9.81 multiply bracket 13.3 plus 680 into 0.23 bracket close. So shift so I get the answer 2.6038, so which will give you Reynolds number RE is equal to nu D sorry VD by nu. So V is 2.6038 into 0.15. So this is capital D divided by nu. Nu is given as 1.01 into 10 to the power minus 6. 1.01 into 10 to the power minus 6. So we'll get Reynolds number approximately, no need exact, approximately. So we'll make the Reynolds number 2.6038 into 0.15 divided by 1.01 exponent minus 6. The Reynolds number is the Reynolds number is 386702. So means around 1, 2, 3, 4, 5. 3.8 into 10 to the power 5. And from Moodi chart, the Reynolds number is 5. And RE is equal to 5 into 10 to the power 5 from chart. So our assumption is wrong. So first trial is wrong. So first trial is wrong. So let us from this Reynolds number we will find the friction factor from the chart. So at RE is equal to 3.8 into 10 to the power 5, around 4 into 10 to the power 5, and xi by d is equal to 0.0017. We will find the F from chart. F is equal to, so go to the chart, and now from this line, this is a 4, go up with this, and it will cut to this. So this is a 4 line, so go up with this line, it will cut here, and the friction factor is again 0.0 So f is equal to 0.023. So there is no change. So we'll assume this is correct, and the Reynolds number 4 pi is around same. So second assumption. So from chart, f is equal to 0.023 at Re is equal to 4 into 10 to the power 5. So we'll assume this and find the velocity and the discharge. So Q is equal to, so velocity V is equal to now assume. So we'll start this by trial and error method. F is equal to we'll assume f is equal to 0.021. Okay, let us assume, and psi by d is given to you. That is a psi is a manufacture surface roughness for the given pipe, and it is depends on the pipe. So it is given to you 0.0017. So go to the Moodi chart and find out. So go to the Moodi chart now. Moodi chart. So f is equal to. So this is a Moodi chart. So on y-axis there is a psi by d. Another y-axis there is a friction factor f, and Reynolds number here on x-axis. It is given psi by d 0.0017, around near to 2. Okay, now we will draw the parallel line from this. So this is a parallel curve for psi by d 0.017. So now first assumption, we assume f 20, 21, 22, 23, 24, 25. So this is 20, 21, 22. So 0.022. So we'll come here along this line where it cuts here. the Reynolds number is around 9 into 10 to the power 5. Okay, so this is 10 to the power 5, 9 into 10 to the power 5. So for first assumption, so I will write, it will give you a Reynolds number is equal to 9 into 10 to the power 5. Here we can find out velocity and friction factor, we can check it. So this will give you a Reynolds number is Vd by nu. So V is, I don't know, V into 0.15 divided by 1.01 into 10 to the power minus 6. So this will give you V is equal to, so 6.06. So put this value in the equation. So equation is up here, the velocity and h, and find out f. Whether it is same, then our assumption is correct. So h1 is equal to, so from equation h is 10 is equal to v square by 2g, 6.06 square divided by 2 into 9.81 into 13.3 plus 680 f. So here this will give me f is equal to 0.0117. So this assumption, our assumption is wrong. Okay, then second assumption, assume number 1. Number 2, f is equal to 0.023 and psi by d is equal to 0.0017. So this will give me Reynolds number is equal to, from chart, so Reynolds number is equal to, you can see and go to the chart. So 0.23 here, 0.023. So I will draw the line this and shift, yes, here. Then then I will draw the line from, it is touching here around near about 4. So Reynolds number is 4 into 10 to the power 5. So we'll write back. So Reynolds number is 4 into 10 to the power 5. This will give me the velocity v into 0.15 divided by 1.01 into 10 to the power 6. So this will give you v is equal to meter per second. So we can 2.69. Okay, and now I will check the friction factor from the chart. So from equation 10 is equal to 2.69 square divided by 2 into 9.81 into 13.3 plus 680 into f. So this will give me f is equal to 0.020. Okay, so 23. So before 21, 23, and we are varying here, so we'll assume f is equal to, so finally f is equal to 0.022. So from equation 10 is equal to v square divided by 2 into 9.81 into 13.3 plus 680 into F is equal to 0.022. So we'll get V is equal to, we'll get velocity is equal to 2.634 meter per second, and hence discharge Q is equal to AV. A is, as already we found out here, 0.0177, 0.0177 into 2.634. So we'll get Q is equal to discharge 0.0476 meter cube per second. So this is our answer. Q discharge is equal to. Now B option. So if you go B, determine head loss H1 for Q is equal to 60 liter. So H is equal to how much when Q is equal to 60 liter. H is equal to, determine head loss H, Q 60 liter per second. So 60 liter per second. So 60 into 10 to the power minus 3 meter cube per second. So we have equation H is equal to V square by 2G 13.3 plus 680 F. Q is equal to AV. So 0.0177 into V is equal to 60 into 10 to the power minus 3. So I will get V is equal to 3.3953 meter per second. So which will give me a Reynolds number RE is equal to capital D by nu. So 3.3953 into 0.15 divided by 1.01 into 10 to the power minus 6 is equal to 504253. Okay, so it is approximately 5 into 10 to the power 5. So from chart, see in this equation, we know velocity, but we don't know F and H. So F and H is unknown. So I know velocity. So I will use the chart now. From chart, at xi by d is equal to 0.0017 and Reynolds number is equal to 5 into 10 to the power 5. I will get F. So go to the chart, and Reynolds number is 5. So from this line, so I will delete this. I will draw the line from 5. So we will draw the line. So near about here. Then I will draw the line with this, and here I am getting F is equal to 23. Okay, so from chart I am getting 0.023. So put this value in this equation and we'll get H. So H is equal to V is 3.39. So 3.3953 into square divided by 2 into 9.81 into 13.3 plus 680 into 0. F. 023. So the answer is H is equal to 17.004 meter. So second assumption is very simple, because a discharge is given, velocity is given. Okay, discharge is given, velocity is given, so Reynolds number, we can find Reynolds number, and from chart we can find out discharge. This is a simple problem. A horizontal pipe has sudden expansion, so it is very simple problem, and if you solve it as it is, so when K is given, it is very easy to solve. So we'll write the given data. KSE sudden enlargement is given as 0.5. Okay, a horizontal figure. The water velocity and pressure at the smaller pipe are given. See, calculate pressure P2. So pressure P2 is asked. After expansion, flow is steady. So what is given? So T1 is 8 centimeter, is equal to 0.08 meter. V1 is given 10 meter per second. P1 is given 30 kPa. Then D2 is given as 16 centimeter, is equal to 0.16 meter. The density is given and J is given. Net one flow is steady flow. Q is equal to A1 V1 is equal to A2 V2. V2 is equal to, this will give me V2 is equal to A1 V1, A1 V1 by A2. A2 is equal to pi by 4 T1 square V1 divided by pi by 4 D2 square. So it is nothing but T1 square V1 by D2 square. Or you can find out area and put the value A1 into here. So 0.08 square into V1 is 10 meter per second divided by A2. D2 is 0.16 square. So we will get V2 is equal to 2.5 meter per second. So apply the Bernoulli equation between 1 and 2. Apply Bernoulli's equation across 1 and 2. So P1 by gamma plus P1 square by 2G plus Z1 is equal to P2 by gamma plus V2 square by 2G plus Z2 plus HL. So there is no other losses, there is no interest loss, there is only one head loss at sudden enlargement, which is given, where HL is equal to KSE into V square by 2G. So this is sudden enlargement, so we need to take V1 square. P1 is equal to 300 into 10 to the power 3 kilopascal per and gamma for water, so this is a water is flowing, so gamma for water is 9810 plus 10 square 2 into 9.81 plus Z1 and Z2, the horizontal pipe, it get cancelled. 0 is equal to P2 I don't know, 9810 plus velocity is 2.5 square divided by 2 into 9.81 plus Z20 plus 0.5 SE KSE and V is 10 square divided by 2 into 9.81. So solve this equation, you will get P2 is equal to 321,875 Newton per meter square is equal to 321.875 kPa. Okay, so this problem can be modified as we don't know this K. Why it is given? All the diameters are given, so we can find out K SE. So where here if it is not given, if KSE is not given, if not given, then we can find KSE is equal to 1 minus d1 square divided by d2 square whole bracket square. Okay, and then v1 square, so we can find out K value. So same some will get here 0.5225 or something, and you can put this value whatever is here. Okay, so this is unnecessarily, maybe if it is given or not given you can find out.